Hi, my name's Colin Eberhardt. I'm the CTO of a consultancy called Scott Logic. I've been involved with FINOS for, well, ever since FINOS existed. Now, many of us see AI as transformational, but I don't think many of us would agree that the transformation's happened yet. We have a sense that the transformation is happening, but we haven't quite arrived there yet. What I want to do is discuss some of the challenges that are getting in the way of genuine AI transformation. What are the things blocking our path? Now, it's fairly standard practice in talks to do a brief history of the thing that you're talking about. And I thought I could do a brief history of AI, but so much has happened in just the last 3 or 4 years that we'd be here for the rest of the night if I gave you a sort of brief history of generative AI. So instead, I'm going to do a brief history of the last 4 weeks in AI. And let's see what's happened in the last 4 weeks. So around about a month ago, OpenAI released GPT-5 Codex, which is a code-optimized version of the GPT-5 model, which was itself only launched about 2 months ago. Now, as a result, this has now become a worthy competitor of Anthropic's Claude model, which was the leading model for software development. So it was a pretty major release for OpenAI. And in order to showcase its capability, the ICPC is the International Collegiate Programming Contest. It's a contest where some of the brightest and best developers get together into a room and try to solve 12 coding problems within the space of about 6 hours. GPT-5 answered 11 out of the 12 questions, and Gemini, I think, managed to get around about 8. What's really notable here is these aren't models that were designed for coding competitions. This isn't like the AlphaGo of coding. This was GPT-5, and it wasn't even GPT-5 connected to a web browser and the internet. It was just GPT-5 and an execution environment, and it achieved this astonishing result. What else happened? Well, NVIDIA invested $100 billion in OpenAI, and OpenAI agreed to spend that money with NVIDIA and buy lots of chips. And I must admit, I love this picture of Jensen. It makes it look like he's rocked up at a street corner and is about to sell you some GPUs. Anyone want a GPU? It's a brilliant picture. On a slightly more sad note, Accenture announced that they were exiting around about 11,000 staff, saying that they couldn't reskill them in AI. And this is starting to turn some of the fears that some people had about AI displacing jobs potentially into a reality. And it's certainly a reality for some of the staff at Accenture. And in a similar sort of story, the metaverse chief sent around a memo setting the expectation that his team should be working 5 times faster due to AI, which I think is very generous, because most people are looking for a 10x engineer. So, I think that was quite kind of him. What else? So GPT-5's lead was very, very short-lived. About 2 weeks later, Anthropic announced Sonnet 4.5, their latest generation of their coding model. And its performance was really quite impressive. On the SWE, software engineering bench, it achieved a score of around about 80%. Now, if you're not familiar with this benchmark, it's comprised of around about 3,000 real-world issues from GitHub. So this isn't a sort of academic exercise. It's using AI models to perform human-like tasks. And what's even more notable is just over a year ago, the state-of-the-art models were only scoring about 25%. Now they're scoring 80%. Also, they reported that Sonnet 4.5 could work autonomously for around about 30 hours. And it feels like that's almost a new benchmark. How long can your agentic AI coding application work autonomously for? Other news. OpenAI released the latest version of their video model called Sora 2. They also released it alongside an AI social media short-form video platform. So we were promised AGI, we were promised a cure for cancer. What we get is AI slop. Thank you, OpenAI. Another deal, and again, this is just in the last 4 weeks. It's nuts. This time, OpenAI pledged to deploy 6 gigawatts of AMD chips, and an interesting deal with warrants that allow them to buy 10% of AMD stocks. As a result, the AMD share price jumped by about 30%. A similar story to what happened with Oracle about 6 weeks ago, so it didn't quite get into my little time window here. Funnily enough, this deal-making and this sort of circularity has caused renewed calls that potentially we're seeing a bubble here. Interestingly, at the OpenAI Dev Days event, Sam Altman was interviewed, and he said things are kind of bubbly. He didn't quite say that it's a bubble, he said it's kind of bubbly. And then, I guess, on a more practical note, the previous speaker actually mentioned this. Anthropic just 6 days ago announced Agent Skills, which is a new way to plug tools into large language models. And if you've been following the progress of large language models, tool use and reasoning are two of the capabilities that have caused them to have significant increases in capability. The tool use and reasoning are what allowed GPT-5 and Gemini to do so well on the ICPC challenge. Now, I have a feeling that agent skills are going to look MCP, which everyone's gone nuts about, look pretty dated quite fast. Where MCP is more of a formal specification and has a certain rigidity to it, skills play more to the strengths of large language models. They're a little bit more relaxed in their expression. Also, they depend on the large language model having access to an execution environment. So they rely on the large language model being able to execute code, which is fundamentally what gives large language models quite a lot of superpowers. So I think MCP is going to be a bit like XHTML, whereas skills are going to be more like HTML5. I have a feeling this will be the future direction. And that was just 4 weeks in AI, or to be honest, the bits that I could remember. There was a whole load of other things that have gone on in the past 4 weeks. It's astonishing. We've had model releases, we've had platform releases, we've had product increments. It's moving at an incredible pace, and keeping up with it is a full-time job. Also, the narrative has changed recently. It's gone from artificial general intelligence, or AGI, to artificial superintelligence. We don't talk about AI anymore, we talk about agentic AI. We don't talk about AI-assisted software development, it's all vibe coding these days. A lot has changed, but I can't help but ask this question of myself. Has AI actually changed my life? And in all honesty, at the moment, I think I'd have to say no. I mean, I certainly talk about it a lot, but I used to talk about other things beforehand. Talking's not new. But my day job is largely the same, and my personal life is mostly the same. I mean, I can create complex greenfield applications using agentic AI tools, but enterprise software development, that's still pretty hard. And to be honest, consumer products are still quite underwhelming. I mean, I haven't had the update to Alexa yet. My Alexa's still really, really dumb. So the benchmarks have been smashed. It doesn't really matter what benchmark this is. You look at a benchmark, it'll be a bunch of dots that go up really quickly in a very short x-axis. It doesn't matter what it is. We've got PhD level intelligence. The models are amazing. But the thing that we're missing is the products. It's the products that connect technology to people and actually improve our lives. That's the thing that we're missing at the moment. So I don't mean to sound negative, and I know that the sort of review I gave of the last 4 weeks of AI was more of the funny bits, to be honest. I do think this is an incredible and transformative technology. But the problem with transformative and disruptive technology is it's not something that you just adopt. It necessitates change. And the more transformative, the more disruptive the technology is, the greater the change that has to take place for us to be able to capitalize on it. So what I want to do is quickly take a look at some of the aspects and the qualities of this technology that I think make it really hard to adopt, and also make it really quite hard to develop products at the moment. So the first one is, large language models don't know what they don't know. So you've probably heard of hallucinations. I think they are the most well-reported weakness of large language models. Their ability to create plausible yet entirely false statements. They have another weakness, and I think this weakness is even more problematic. Large language models have a very poor understanding of their own limitations. And you've probably experienced this yourself on a number of occasions, but what I want to do is bring this to life with an example that I had quite recently. So the other day, I had a pile of Lego, because, I'm a geek, I still play with Lego, and I took a picture of it, and I asked, what could I make with this Lego? And it answered, from what I can see, these Lego pieces are primarily grey, white, blue, and it came up with a few ideas. A spaceship, a starfighter, a mech, or a robot. I thought, that's pretty good. I quite like that. I said, I'd like a starfighter, and can you please render an ice image? So it went ahead and rendered a really quite believable image. So the next thing I did was say, great, give me instructions for how to build that. It gave me instructions, and I built it. This is what I ended up building. This is the instructions that it gave me. For that impressive-looking starfighter, that's what I got. Now, as you can see, it's laughably wrong. It had no inherent understanding that it was not up to this particular task, and it quite happily, with the odd emoji, spat out this markdown document and let me build it. I went a step further. I said, how do you think you performed on this task? How accurate do you think your instructions are? It said, 70 to 80%. I disagree. I think it was a lot worse than that. And the problem is, you will see this same thing manifest itself time and time again. How many times have you asked ChatGPT or Claude Code a question and for it to come back and say, sorry, I can't do that. That's beyond my capabilities. I've seen people do things like use ChatGPT to design some DIY task, and it looks brilliant as a rendering, and then they ask it to give them the measurements, and it gives them the measurements, and they're gibberish. This happens time and time again. Now, there's another issue that I want to talk about. Now, this is less about a limitation of the models and more about the limitation of the interfaces that we are designing around the models. And I call it the blinking cursor problem. So we have a general purpose AI that can use human language as a way of communicating. It's incredibly versatile, it's incredibly accessible. How do we present it to the user? Like this. What can I help with? I don't know. Can you give me some instructions for building Lego, perhaps? Maybe? What about Perplexity? Do they do any better? No. What do you want to know? I don't know. What about Claude? Good afternoon. OK, well, at least it knows my name. But this is a recurring theme here. We have a highly versatile tool. It's a linguist. It's a mathematician. It's a programmer. It's a poet. It's also a tool that hallucinates. It's unaware of its own capabilities. All of this is hidden behind a simple, empty box. There's barely the mildest hint of what it can even do or not do. We give it to the user and say, it's your move, you work it out. And funnily enough, this reminds me of the very first computer that I owned. And some of you will be old enough to remember this one. This was the BBC Model B computer. And computers of that era had exactly the same interface. They had a blinking cursor. And they were quite unforgiving. If you were able to type in the right things and form your own understanding of what it can and cannot do, you could be quite successful. Funnily enough, we're giving people exactly the same, really quite limited interface. But one of the things I also find quite interesting is I've mentioned a lot about some of the weaknesses that are hidden in these systems. It's just as good at hiding some impressive strengths. And here's an example. I know the text is a little bit too small here, but I was using ChatGPT and various tools to do some simple development of applications. This isn't the application I was building, it's a slightly more trivial version. And one of the things I was doing was I was writing a specification, because when you're working with AI coding models, often you're more productive if you give them a significant amount of information as a specification. And I thought, I'm bored of writing a specification, I'd like ChatGPT to help me do that. So I said, take on the role of a business analyst, engage with me in conversation, ask questions about a game I would like to develop, ask questions one at a time, keep the conversation flowing, don't talk too much. Which you have to tell these things, don't talk too much. And it did a fantastic job. Over a 5-minute conversation, it asked me a whole load of questions, and when it had decided, it had extracted enough information, it said, right, here's your specification. This kind of role reversal is a hidden strength that not many people are aware of. You can do this with pretty much any conversational AI. It's amazing. So there's a couple of problems. As I mentioned, we've got a PhD-level physicist that cannot tell me whether it's any good at making Lego or not. We've got an interface that's incredibly simple but lacks any suggestion of its capabilities. These are just illustrations of a couple of the challenges that we face in adopting this technology. So whether you use AI to write code, prose, or make decisions, these problems and others will manifest in various surprising ways. And this is what makes it such a hard technology to adopt. One of the things I did a little while back was look at the launch of the iPhone. So many people compare the transformative effect of generative AI to the iPhone or the internet. We expect it to have this much impact on our lives. And I don't know if any of you have watched Steve Jobs doing his iPhone presentation. It was a brilliant presentation. And he gets people really excited. And the peak of his presentation is where he repeatedly says, today we've launched a music player, an internet communicator, and a phone. And he repeats those words 2 or 3 times, and then lets everyone into the secret. This is all actually bundled together in a single device. So what's notable there, though, is these are 3 things that people were already entirely familiar with. Everyone in the room already had a music player. Everyone knew about internet and internet communicators, and everyone had a phone. So once they bundled them all together, it was obvious how to use this technology, and it was obvious to everyone in the room that this was going to be a runaway success. They were already familiar concepts. As I've demonstrated, there are so many concepts. Well, I've given you 2 examples, but I could keep going. There are so many examples with AI where we are hitting against concepts that are not familiar, and that is one of the things that's really going to limit the adoption. We'll get there, but personally, I think it's going to take at least a decade to start solving some of these problems. Also, AI has far-reaching impacts. It's got risks and opportunities in equal measure. The impacts span the offerings that we have within our businesses. It impacts our people, where AI is reshaping the way that they do their jobs. It impacts our business operations, the processes that make our businesses tick. And as I mentioned, we see risks and opportunities in equal measure. And again, this is very different from the likes of the smartphone, where, again, it was a revolutionary technology, but it didn't quite have the same breadth of impact. So for the purpose of this talk, I want to focus on what I think is the most important part of this transformation. And at the moment, I think one of the most important things is a readiness problem. So just to bring it back into the context of FINOS and some of the activities that we've been undertaking here, I can't recall if Gab showed it on the stage earlier, but I've been involved in the State of Open Source in Financial Services survey and report a few years running. And a couple of key themes have emerged as the biggest challenges and biggest hurdles that financial services organizations are facing when adopting AI. The first is governance and a lack of suitable frameworks to allow them to capture and understand the risks and put in place mitigations. Interestingly, this year, there's been a reasonable drop in the number of people reporting that to be a problem. Now the biggest problem faced by most organizations is skills and an understanding of this technology. So in the interests of doing something practical to solve some of these problems, it was around about 1.5 years ago that we launched the AI Readiness Special Interest Group. So our goal, as stated here, was to develop a governance framework that manages the onboarding, development, and running of AI-based solutions in financial services. And one of the things that we did was a group of us got together and created an AI governance framework. And it's now comprised of around about 46 risks and mitigations, 33,000 words. We also have 8 mappings to different frameworks, things like NIST, things like OWASP, and it's been rapidly developed over, I think, getting on for a year now. We've just done our version 2 release. We're looking to create closer integration with CCC. We were talking just about an hour ago about integration with CALM, a framework for modeling architectures as code. So we're looking to integrate it into some of the other FINOS projects. And again, the goal here is to help financial services organizations adopt AI. So as a bit of a parting thought, putting this technology into people's hands is the first step, but it's a surprisingly challenging technology to adopt. So one of the other things that I think we need to do, which is, as well as putting the technology into people's hands, we need to give them a safe space for them to learn about the technology. A number of the issues and the challenges that I've already described are ones that I don't think are going to be immediately solved by technology itself. We've already seen that the hallucination problem is something that has been minimized, but it's something that's not been eradicated. I think the lack of a large language model to understand its own capabilities, I don't think that's something that we're going to solve for a long time. So what that means is we need to form a better understanding of the capabilities of this technology to then be able to effectively use it in our own lives. In order to do that, though, we need to create safe spaces for people to actually play and experiment with this technology. And by safe spaces, I mean allow people to use it in a way where failure is an option. So some organizations are very much pushing and mandating the use of AI. Meta, as I mentioned earlier, are expecting people to become 5 times more productive. I think this kind of thing needs to be done in a much more sensitive fashion. You have to understand that there's a lot of learning people need to do in order to make good use of this technology. So I think safe spaces, sandboxes, and gentle encouragement, to my mind, are the best way to get people to understand what they can and cannot do with this technology. So finally, as a sort of parting thought, if you're not using AI on a daily basis, and I hope most of you are now, you should be. And if you're not encouraging your teams to do the same, then I think you should be as well. I'm not going to pretend that's going to solve all the problems, but it will certainly get you on the journey. This technology is rapidly evolving, but it's hard to describe. It's hard to understand. It's wonderful. It's surprising. It's also quite infuriating at times. And experience and getting a feel for it is very much the key. AI adoption is very much a transformation problem. And we have to be prepared to learn and experiment, but ultimately we have to be prepared to adapt. We have to change the way that we work to make the best use of this technology. Thank you very much.